They're showing themselves for who they really are, folks.
So it's like at this point,
There's some really concerning research from China. What the researchers did was they got a virus from a pangolin. That's these charming little creatures that are so abused throughout Eastern Asia particularly. They took a virus from the pangolin and they cultured it in cells in the laboratory. And they then infected mice with it. And it killed all of the mice that had infected through brain infection. So they've generated this new virus that kills 100% of mice it's infected with, but it gets worse because the mice that were infected were humanized mice. Now, these are called transgenic mice. In other words, they were given some human genes and they were given human ACE receptor genes that were expressed by the mouse. So these are essentially human ACE receptors in genes, and it killed 100% of the mice that were infected. And these are the things that they are jiggling around with in laboratories. This is absolute madness. And that virus, my understanding from reading of the paper, was it evolved in cell cultures in a laboratory. So as a result of going through cell cultures in a laboratory, the function of the virus had been increased. It would appear it became a more functional virus. There was a function, and there was potentially an increase, maybe even a gain. Anyway, but we know it's out there. So they know it's out there. Obviously, they don't know a precise geographical location, but they know it's out there. And we know it has the potential to spill over from animal populations potentially into humans. Well, yeah, there can be natural spillover events, of course. There can also be other origins of viruses. Perhaps mutate or adapt itself and then begin spreading and killing people faster than we can contain it.
Let me show you how we do stuff.
biggest headline-grabbing product in the modern world of brain-computer interface, Elon's company is really just one piece of a much larger puzzle that neuroscientists have been trying to solve for decades. How do we understand the human brain? The pursuit of decoding the human brain will become a multi-trillion-dollar industry in the decades to come, and Neuralink will have no shortage of competition. But in true Elon Musk fashion, his radical pursuit of innovation might stand the best chance of coming out on top. Synchron is another US-based BCI startup company that has already completed their first round of human trials in 2023, implanting 10 patients with their own neuron-sensing electrodes. This company is important to watch because it is currently being funded by Jeff Bezos and Bill Gates, two wealthy and powerful individuals who do not seem to like Elon Musk very much. The method used by Synchron to access the brain is considerably less invasive than the procedure being done at Neuralink, which is a big factor in allowing human trials at Synchron to move at a faster pace. Instead of approaching the brain through the skull, Synchron uses a stent-based procedure that they call a stentrode. A stent is basically just a wire that is inserted into a blood vessel, which is just a large vein. They're like the highways of the circulatory system. Typically, doctors will use a stent to free up a blockage inside the vessel that might cause a heart attack or stroke. In the case of the stentrode, the device is using a primary blood vessel as an express lane directly from the chest into the cerebral cortex. Once the stentrode arrives in the brain to an area directly below the motor cortex, an expandable mesh is deployed that interfaces with the walls of the vessel. And this mesh contains 16 electrode sensors that can begin detecting and transmitting neural activity back down through the wire and into a device that is attached to the patient's chest. So how does that compare to Neuralink? Well, let's go back to what we were just talking about at the beginning. The first Neuralink patient has had 64 tiny wires inserted into the surface of their brain by an ultra-precise surgical robot, and each wire contains 16 electrodes just in the microscopic tip that goes around 2 millimeters deep into the brain tissue. That is a total of 1,024 individual electrodes that are distributed across the circular hole that's been cut into the patient's skull. And then, looking at our stentrode again, we have 16 electrodes placed inside a blood vessel that is adjacent to the brain material we want to monitor. Even with this significant disadvantage on paper, in practice, the Synchron BCI is currently able to achieve the exact same function that Neuralink is demonstrating with their current telepathy system: basic control over a keyboard, mouse, and smartphone device. And Synchron currently has 10 active human patients in their initial feasibility study that began in the summer of 2022. So, a pretty significant head start in product development. But the biggest problem with Synchron is that they've already pretty much reached their full potential with the stentrode system. Controlling a smartphone telepathically is about all that this particular style of implant can really accomplish, which is still cool, but it doesn't exactly provide much of an outlook for the future. While if we apply the same logic to Neuralink, then we can assume that the current telepathy application is only using something like 1/64th or less of the total potential that the hardware is capable of, which gives Neuralink a long-term outlook that is almost beyond comprehension. Elon Musk has speculated a lot of potential outcomes like curing brain disease, correcting mental illness, ending obesity, and interfacing the human brain with an artificial super intelligence. Now, there is obviously no evidence to say that Neuralink actually can do any of those things, but there's just as little concrete proof to say that it can't. All we really know is that we don't know the full potential of the Neuralink hardware, but we can take a look at another BCI technology that is as close to Neuralink as anyone else has come. This is BlackRock Neurotech. It sounds like a scary name, and it kinda is. BlackRock, along with another company called Vanguard, are famous for owning the entire world. BCI Technology is one of the longest plays that BlackRock has been involved with, conducting their first human trial almost 20 years ago. BlackRock Neurotech are one of the pioneers of the invasive BCI, which is the same category that Neuralink falls under, meaning that the operation has to go in through the skull and gain access to the surface of the brain. Obviously, microscopic electrode wires and high-precision surgical robots didn't really exist 20 years ago, so the best option available at the time was an array of stiff, straight electrode pins. Due to the larger size and rigidity of the pins in the Blackrock array, they can't penetrate as deep into the tissue as a Neuralink thread. But even still, that direct connection through hundreds of electrode pins can provide a significant amount of bandwidth between the brain and the computer. Even with their relatively primitive approach, BlackRock has already demonstrated telepathic control over a computer many years ago. They've allowed people to control robotic arms just by thinking. They've even allowed a man who lost the use of his legs in a traffic accident to walk again on his own. So, while their technology approach may be a bit primitive by modern standard, the list of accomplishments at BlackRock is extensive, something that will take Neuralink a very long time to match. But it won't take them very much longer to exceed. If the Blackrock array can seemingly perform miracles with hundreds of electrodes penetrating 1 millimeter deep, then what can be accomplished with thousands of electrodes going 2 millimeters deep? So again, the long-term perspective is what makes Neuralink so captivating. There is no other device on the market, or even in concept, that will provide such a high bandwidth connection between brain and computer. And Neuralink is literally just getting started. This year is going to reveal some crazy discoveries that will redefine what we consider to be possible with the human brain. So